my name is Mary Ann. Today we are going to talk about experiment 20, which is basically about the cross-flow heat exchanger. So what is a cross-flow heat exchanger? It is basically used for cooling and ventilation system that requires heat to be transferred from one airstream to another. And the main objective of our experiment today is to investigate the different types of tubes and the heat transfer coefficient in the cross-flow heat exchanger. Basically, there are three types of tubes used in this experiment: the single tube, tube bundle, and fin tube bundle. And the other manipulating variables of this experiment is the iris control diameter and the rows of the bundle. The experiment is repeated with three different iris diameter and three different rows for the tube bundle and fin bundle. And graphs of ln Remax versus ln Nu can be plotted based on the results obtained from this experiment. And based on these graphs and the results obtained, the heat transfer coefficient can be calculated.
Hi guys, my name is Jane. So I will be talking about the methodology of this experiment. In this experiment, there's general setup before we start the experiment. So we'll switch on the main power, and there's three different kind of tubes here. The one I'm holding is single tube, this is bundle tube, and this is fin bundle tube. So we will start with the single tube experiment, then we will change it after that. So after you insert the respective plates onto the vertical air, which is here, we will switch on the blower and heater and turn the iris. The iris is controlled by here, and then we will set the heat power to 5 watt. Since as mentioned earlier, these are one of the manipulated variables is the rows of the tubes. So for bundle tube and fin bundle tube, we will repeat the experiment 3 times with 3 different tubes and 3 different rows and with 3 different numbers of iris control. After that, we will record the data here from data logging, and then the experiment is done. So how we shut down this equipment is we need to reduce the heater to the minimum first. After that, we can only turn off the heater power and the fan. Then we switch off the main power. Thank you.
Hi, my name is Muhammad Jazli Alkami Zanamuddin, and now I'll explain about the result and discussion for this experiment. So basically, for these 3 type of tube, as the number of iris increase, the air velocity will also increase. So as the air velocity increase, the amount of Reynolds number will also increase. So as the Reynolds number is increased, the Nusselt also will increase. Then this will lead to increase in heat transfer coefficient. However, the fin tube bundle has the highest heat transfer coefficient compared to the single tube and the bundle tube.
Hi guys, my name is Muhammad Zikri Abdul Razak. So as a conclusion, the heat transfer coefficient is the highest if you use the fin tubes followed by a bundle tube and then the single tube. The fin tube produces the highest heat transfer coefficient due to the geometry of the tube itself that allow more heat transfer happen in its surface. And then the more heat transfer available for heat transfer, the higher the heat transfer coefficient. And also, the more tube used in heat exchanger, the lower the surface temperature. This means that the single tube has the highest surface temperature compared to others. And then the arrangement of the tube in heat exchanger also plays an important role on the effectiveness of the heat transfer process. To design a good heat exchanger, we must need a large surface area of the tube to allow more heat transfer, and then more number of tube, and then tube arrangement need to be close to each other.